Hi class, in this video we'll be looking at the chapter 2 presentation from the textbook and thinking about creating some notes. So I'm going to go back to my OneNote notebook that I still have open. It's going to rebuild here slowly because I have so much going on. And I'm going to add a new tab, and this is going to be chapter 2 data types. Now, the first thing that I want to keep track of are just some notes, and then I know that I'm going to want to add another page for some syntax. So I saw that last time, that those are going to be some general things that I'll want to keep track of. Okay, I'll minimize this back down and look at our data types and expressions. As we begin, remember that any programming language is going to need to figure out some way to declare variables that can represent data in the program. These data elements are going to be saved in memory, and we would like to assign a name or an identifier to that given location. We're going to explore how variables are related to classes and objects, and how the different data types are assigned. All of these topics should be familiar to you from your introductory programming course. The order of operations will help us when we're looking at math statements. We'll look at some formatting options for how we can output things in a nice format. Whenever we're working with a computer, we need to be aware of binary and how data is represented internally within the system in memory. And we know that in memory, data can be represented in a binary format. Binary is a combination of 8-bit sets, and each of those bits is one binary digit, and a binary digit is either 0 or 1. Now there's a video available that explains how to convert from binary to decimal, and it's separate, so go ahead and do watch that if it's not something that you're familiar with, because it's really important for us to have that foundational knowledge of binary. So I'll click through some of these slides just to remind you how important this is. Now, we can convert binary numbers directly to decimal numbers, but if we want to encode some other kind of data to be saved in memory, like characters or special characters or things like that, we have to have some sort of code set. We have a couple of those available. Unicode is the code set that's used by C#, and ASCII, the American Standard Code for Information Interchange, is a subset of Unicode. It's the first 128 characters. So originally we had ASCII, the ASCII code set, and then it was expanded to add all of these additional 60,000 and some characters. So a lot of different information can be represented. When we're using Unicode, we're talking about 2 bytes or 16 bits used to represent a unique character, and we have a lot more capabilities there when we do that. When we're working with bits and bytes, we're working with really small amounts of memory, but we add those all up to create larger amounts of memory or storage space. You can see here that all of our numeric representations that we have that we're used to hearing in regards to computer systems are based on powers of 2. So a kilobyte is 2 to the 10th power, or 1024. A megabyte is about 1,000,000 bytes, and it's 2 to the 20th power. A gigabyte is about 1,000,000,000 bytes, and it's 2 to the 30th power. We can see a lot of patterns here. A terabyte is, beyond 1,000,000,000. Now we start getting into not naming them different things. That's 2 to the 40th power. Petabyte is 2 to the 50th, exabyte, and we can go up to a yottabyte, and that's a whole lot of yotta storage, isn't it? And we need to be aware of those kinds of things, that it's all based on the powers of 2, because that creates some nice number patterns for us to work with in certain situations. Now, whenever we work with variables and data that we're saving in memory, we're going to use an identifier. An identifier is simply a name, but we need to remember that term, identifier. Whenever we're naming things in C#, we can use alphabetic characters, numeric digits, and the underscore. The first character in the name cannot be numeric. We can't have any spaces. That would make 2 variable names. Keywords can't be used because, well, they're keywords. And we want to use character casing to our advantage by using upper camel case, lower camel case, those different options where we can start with a lowercase letter or start every word in our variable name with an uppercase character. And we want to be descriptive, but we don't want to have such long names that our code is basically unreadable. Here's a list of all the keywords. Visual Studio is super nice and turns them blue for us. So if you have a variable name that has turned blue, it's not because Visual Studio strongly approves of it. It's because you have accidentally used a keyword. Now we can use different keywords in different contexts. So a contextual keyword can be very powerful, but it might only have meaning when it's used in a certain place. Other times it might be usable as an identifier. So we also have to be aware of those contextual keywords. And again, they should turn blue in our code if something pops up. Some contextual keywords are listed here. We can see that we might be able to use the word add, but then if we're in a given situation, that word might become a keyword. Pascal case is where we start the first letter of each word in a capitalized letter. Camel case is where we start the first letter of an identifier in lowercase, and then each word after that has a capitalized letter. We use this camel case for variables and objects. Notice that our variables and object instances are going to start with a lowercase letter. If we name something completely in uppercase, we're indicating that it's a constant or a piece of data that never changes, like the value of pi. So we want those kind of variables named with all uppercase. Here's some valid variable names. They're all awesome. Here's some invalid ones. What's wrong with them? This first one has some spaces. That's really 3 variable names, isn't it? Int is a keyword. Third day can't start with a number. Room number can't have a space, and we can't have that pound sign or hashtag symbol. First dash name can't have a dash. A number can't have space. And then the word class is reserved again. So lots of different things that can keep variable names from being usable, but the number of usable variable names is just astronomical. So when we declare a variable, we're saying that I need to put an area in memory aside where I can keep track of some data. So there are 2 steps to that, basically. First is declaring the variable, saying, hey, I'm going to have this variable that I'd like to keep named A. And then second is actually giving memory to that variable. And that may happen when the variable is declared, or it may happen at a later time. We have some specific syntax here. It's type space identifier, semicolon. That doesn't seem like too meaningful, does it? But it's really important. Let's put it in our notes. So under our syntax, we're going to say that one syntax is type, where's my cursor? There it is. Type identifier, semicolon, and I want that word type to be in lowercase. So for example, if I wanted to declare a variable that was an integer type, I would use the keyword int to specify that it was an integer, and then the identifier would be my variable. So I could name it like that, and then I would close my sentence, my code line with my semicolon. So that's how I declare a variable. So I put that in there. Variable declaration. Now, when I have variables, do I have to always say like what kind of type they are? It looks like it, right? Because I'm saying type and then its name. Well, let's put that in our notes. So C# variables. First of all, the data type is required. We also have some naming conventions, right? All those rules we looked at. I'll let you look at those. We would have like no letter, no number in first position, no special characters except underscore. Can have A to Z and A to Z. So we can make our notes be as explicit or general as we like. Now, some other things about our variable names. We decided the name is called the identifier. So lots of great things. Now, when we declare a variable, we can also initialize it, and compile time initialization then would occur. As that program is compiled, the variable's value would be set up. And the syntax to do that is data type, identifier, and then the equal sign, and an expression that sets that variable equal to a certain value. So in our syntax, we'll say we could have type identifier equals value expression, and then a semicolon. So I could say int my, oops, I'm getting things going here, my variable equals 5. Now, when I do that, I have created a variable named my variable, and I've given it an initial value of 5. So we called that, if we look at our presentation here, compile time initialization. And when we initialize something, we're just setting it to a beginning value. So nothing super fantastic about that, other than when the program begins, it will already have that value. See if I can spell that right. Nope, still can't. Let's see, can you spell it? There we go. Compile time initialization. Set up our variable at compile time. Okay, so now, what about these types? C# has a lot of different data types we can use. The int type is a whole number, like I set my value equal to a whole number. We can also have floating point data types that have decimal or fractional portions. And types are actually implemented through C# classes. We'll see that most everything in C# is dependent on a class, being that it's object-oriented. So we usually have a one-to-one correspondence between a class and a type. And our simple data type, like an integer, can also be implemented as a class, and then it would become an instance of an integer object. Let's think about some variables here. If I have a grade point average, I maybe could call it as a variable name, grade point average. I would make it a double data type, and I might have some data like 3.99 in that variable. If I were wanting to keep track of an age, I might have my variable name be age, make it an integer, and maybe I could set it to a value of 19. I could have a variable that holds a student's full name. I could call it student name, and this would be a string variable, and I could have a value like Elizabeth Hill. My char data type gives me the ability to hold just a single character. I could have a variable like that named course grade, and it could hold like the letter A. That'll be what everybody's grade is, right? Whenever I'm working with these data types, I'm working with the .NET Common Type Systems. So I actually have two different types of data, value types and reference types. So let's put that in our notes. I'm going to go back. Common type system. So in my notes, I want something here about, let's say, two common type system, CTS, and this is from .NET, and we have two types. Reference and value. Now, of these two types, I can take a look quickly and determine what things are. First of all, a value type contains the actual data, contains the values. A reference type is more of a pointer in memory that says, oh, I can tell you where this thing is that contains this value. So a reference type is a pointer to another location in memory. So let's put that in our notes. Value type contains an actual value for data. A reference type contains a pointer to a value type normally. So it is in memory as a pointer. Pointer reference. So we can just keep track of things that way. Now, these are important to us in how C# is keeping track of things and saving things in memory, and how we can make our programs more performance optimized. When we're working with our value types, we have, again, a couple of different types of value types. We have structures and enumerated types. And some of our struct types are like numeric things like integers and decimals. We have some Booleans, and we can create some other structure types if we want to. And then enumerated types are types that are assigned a specific value. So here are our structure types that we're very concerned about. We have byte, sbyte, char, lots and lots of different types. Now, the big difference between all these different data types is how much storage do we need, and can we store negative values? Can we store numbers? Can we do math with these different types of data? So we have to make sure that we know what we're working with. This overview gives us some really good information. If we're working with very large numbers like scientific data, we probably want to do a long data type. This gives us a 64-bit number. We can see the range in values is very, very large. So we should be able to do some scientific accurate processing with that. Now, if you notice, we have one fewer here, right? And there should be a minus sign there. One fewer, one less, because a long is signed. And so we have to have that one bit used to indicate whether this number is positive or negative. We could use an unsigned long if we didn't care. And then notice how the size of our number just explodes. Again, it's a 64-bit number. It's using 64 complete different binary digits to keep track of that number. Now, if we don't need something quite that long, we could go with a short. This is a 16-bit integer. You have a really short number, 32,767 is your limit. And if we want to go a little higher, we could make it an unsigned 16-bit integer, and then we would have up to 65,535 values there. Now, a standard one that we use often is the int data type, and this is a 32-bit integer. So again, we can see the range to negative, and then the unsigned integer that goes much higher. So this is going from a negative to a positive. Now, char data type has basically 16 bits, and it can go from 0 to fox, 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 fox within those values, which pretty much gives us a single character. Now, a short byte or sign byte is an 8-bit number that carries a sign, and by default, a byte is an 8-bit number that does not carry a sign. So a little bit backwards here from our other ones, right? A byte can hold a number from 0 to 255, so it's a great data type to use for somebody's age. We don't need to take up all these 32 bits, not right now anyways, we don't live that long. Now here is an example of some code where we have declared some variables, and then we've added a compile time initialization to the age of student, etc. If we need decimal data or floating point data, we can use floating point data types like float. This is a 32-bit number, and you can see the valid ranges in scientific notation there. And a double is a 64-bit, so this is a pretty huge number that's allowed decimal places. When we're assigning values using floating point numbers, we sometimes have to specify the data type. In this example, when we're using doubles, we didn't have to. Everything's just fine. C#'s like, oh, okay, I see 70 with a 0 in the decimal place. But then for this float data type, we had to actually specify this F indicator that says, hey, this literal that precedes me is a float data type, so that the compiler knows how to interpret that number. Now, decimal types are usually something that we're going to use for currency, so monetary items. Again, if we're using a decimal data type, look at that, we have 128 bits, really large number, and we want to make sure that with our accounting systems, we have enough storage to carry the numbers that we need to carry. When we're working with a decimal, again, we might have to use the indicator M to indicate that this is a money amount to go into that decimal data type. Boolean variables give us our standard true false. Strings can be some strings. This string that's 2 lines is interesting. Notice that it's all contained within the double quotes. In the middle we have the \n control character that says to go to a new line. So if this string were output, we would see line 1, then line 2 would be on a separate line. We would not see the \n in our output, but it would affect the output that we do see. When we want to declare constant values, we use the CONST keyword in front of the data type. So let's put that in our notes. CONST. Let's make it double pi equals, there we go. Look, it just filled it in there for me. Isn't that nice? Now, in this constant, the word CONST is a new keyword, and the word double is my data type that was always required for my variable definitions. Then comes my variable name, which I have set all in uppercase because it's a constant. Then the equal sign with the value that's going to be assigned to that variable at compile time. So this is declaring a constant. Once I've declared a constant, the value of the constant cannot be changed anywhere in my code. So I won't be seeing any lines of code that set pi equal to 79 or anything like that. So it's kind of setting up a board or a way that I can keep track of things. Now in a variable that I can change, I can use the assignment operator, which is simply the equal sign, to set a variable equal to a new value. Now that value could be an expression. The expression may be another variable, a literal, like something I've typed in, a math equation, a call to some sort of method that returns something, or it could be a combination of all of these things. So I can start out simple and I can get pretty complex. Here are some examples of assignments. I've declared these integers, and notice this difference in declaration syntax. I can declare multiple variables with one line of code, and I can separate the variable names with commas, so all of those variables will be integers. I set my number of minutes to 45, count to 0, and my minimum integer value to that giant number. So let's add this in. Now in our variable declaration, we saw that we could also do int var1, var2, var3, however we want, and that will declare multiple integers, each with these different integer names. And then I would end with my semicolon. Now an assignment statement. Variable name equals some expression. So notice a really important thing here. The variable name has to come first. So I can't switch them. When I'm working with math, I have that equality thing that says, oh, you can switch them back and forth. I don't care. Well, programming does care. Whatever you want changed, the variable that you want changed has to come first, has to come before the equal sign. So in this example, I could say var1 equals 47. Now, I cannot say 47 equals var1. That doesn't work. No, can't do that. Our variable to be updated has to come before the equal sign. In these examples, we're setting up some initial values for some variables that have different data types. Notice I'm using a single quote if it's a char data type. So all of these char variables are going to be set to values with a single quote. Some decimals. Now, a string can be a little bit different. A string can give me some great options. So I could have a string set to a saying, like first day of the rest of your life, and then a \n to go to a new line. Or I could set up a string that's a file location, like C:\C# projects \chapter 2. When I use that file location, C# is going to get all upset because of all these backslashes and things. I can use this special @ character to make the string be interpreted verbatim. No change. So we can put that in our notes, but it's something that can be hard to remember. So I can use the verbatim. And what I do there is I can say use the @ sign before a string to interpret the string as it's verbatim, Now I have these values in memory, and when I assign them a new value, that memory value is going to change. So I have this value construct here that it's an integer named count, and I started out with it set to 0. Then I set up another variable called new value, and I set it equal to 25. So this is how things are going to look in memory. We have this memory location named count that contains a value of 0, and we have this memory location named new value that contains a value of 25. Now, if I run this line of code that says set count equal to new value, now they will both be 25. I have assigned the value of new value to my count variable. We can also do some math. Let's save that for another video because we don't want these things to get too long. So I hope you're feeling somewhat clear about declaring variables and different things that you can try, different data types. C# is a strongly typed language. Again, we have to put that in here in our notes. C# is strongly typed. So yes, we always have to tell C# what data type our variable is, and C# will make sure that everything will work properly with that data type. So until our next video, thank you.